Okay, guys, in this lesson, we're going to talk about arithmetic sequences, which is a type of linear function. So this means that we will have a constant rate of change, but we will call it something else, but is still a constant rate of change. So arithmetic sequences, that is how you pronounce this. So we're going to look at part one, where we're going to graph the arithmetic sequences, which means our graph will be a straight line. So in our first example, we have a listing of our sequence 4, 6, 8, 10, 12, and so on. So this is our sequence. So to understand that it's linear function and arithmetic sequence, we are increasing at the same rate. So from 4 to 6, we're adding 2. 6 to 8, we're adding 2. Each term, we are adding 2 to get to the next term. So 4, 6, 8, 10, 12, and so on are called the terms. So our rate of change, what we have called slope, is 2. But we don't call it slope, we call it the common difference. So the common difference, common means it's the same, and difference mean we subtracted. From 6 to 4 is 2, from 8 to 6 was 2. So common means it's the same, and the way we got that common value is by subtracting term from term. So we can also see this is increasing, so we're going to have a positive linear function. So instead of slope, we call it the common difference. And instead of m for slope, we use the variable d for common difference. So our word slope is going to become common difference. And the variable we're going to use instead of m becomes a d. Now, let's take a look and put this sequence into a function table. You also notice that instead of x and y, or x and f of x, we have n and a sub n. So instead of n, instead of an x, we are going to now use the variable n, our inputs. And instead of y or f of x, we're going to use a sub n. So a little bit of new notation. Instead of m for slope, we're going to use d for the common difference. For our input values, we're going to use n. And for our output values, we're going to use a sub n. So the sequence terms themselves are the actual output. Now, what position is the 4 in? Well, 4 is my first number, 6 is my second number, my third number equals 8, my fourth term equals 10, my fifth term equals 12. So our positions, position 1, position 2, 3, 4, 5, and so on, those are the input values. So our first term is 4, our second term is 6, our third term is 8, the fourth term in this sequence is 10, and the fifth term is 12. And it does keep going on and on. Now let's look at a vertical function table. So our first number is 4, our second number is 6, our third number is 8, the fourth number is 10, our fifth number is 12, and now that we know the pattern, the sixth number would be 14. So notice in a function table, we are creating our ordered pairs. And we will graph these and decide if we are going to connect the points for a continuous graph or leave it as a scatter plot because it's discrete. So let's take a look at our domain. Our domain, which is represented with n, are the positions. So we're going to use for each curly brackets. We're not going to use interval notation because we don't have like a 1.5 term number. Okay, so we have to list these. 1, 2, 3, 4, 5, and so on. Our range, A sub n, are the terms of my sequence. 4, 6, 8, 10, 12, and so forth is the range. So let's take a look at this same function. So A sub 1, this means what is the first term? This is like y equals A sub 1, because this is usually A sub n. But I've put a little 1 here. That means what is the first term? So A sub 1 equals 4. A sub 2 equals 6. A sub 3 is 8. A sub 4 is 10. A sub 5 is 12. And then we used our common difference to find our sixth number of this sequence, which is 14. So again, we can have 1, 4, 2, 6, 3, 8, 4, 10, 5, 12, and 6, 14. So here is our x-axis, which is going to be our n values, and then our y value is A sub n. So these are our position numbers, and these are the actual sequence values. So I'm going to have a 1, 2, 3, 4, 5, 6, and so on. And then I will just make this easy for myself. So we have 4, 6, 8, 10, 12, 14, and so on. So my first number, so this is my position, and these are the terms. So my first number is 4. My second number is 6. My third number is 8. My fourth number in the sequence is 10. My fifth number is 12. And my sixth number is 14. And we could continue. So let's notice a few things. We have our first number is 4. There is no number in between 4 and 6. So we are not going to connect our data points. So our graph is discrete. I also want us to notice that this linear function does not pass through the y-axis here. This is the y-axis still. And this is our x. We do not, I repeat, we do not have a y-intercept. There's no such thing as a 0 term. We have a first term, a second. So it's always, our sequences are always going to start at 1 comma, whatever that sequence term is. So we have no y-intercept when we're working with a sequence, any sequence, not just arithmetic. Okay, let's take a look at another example. Here we have a sequence 25, 20, 15, 10, 5. We can see we're decreasing. So from term to term, our common difference is -5. So we have a -5 quote unquote slope. So again, I'm going to write the word common difference. This is the language. Instead of slope or constant rate of change, we call it the common difference. We have a first term that's 25. We have a second term that's 20. Our third term is 15. Our fourth term is 10. Our fifth term is 5, and so on. Or if you like the vertical function table, and we're going down by 5. So our sixth term would be 0, and then we'd get into the negatives. So our domain, our n values, we have a first term, a second position, a third one, and so on. And then the range are the output values, which are the sequence terms themselves. So 25, 20, 15, enough values that you can see the pattern. And let's graph this. So a sub 1 equals 25, a sub 2 equals 20. So this would be 1, comma 25. The second number is 20. My third term is 15. Our fourth term is 10. Our fifth term is 5. And our sixth term is 0, and so on. So these are going to be the terms. And these are the positions. We always have a first number, a second, a third, a fourth, a fifth, sixth, and so on. And then let's count by, we can start at, and we can count by fives. We can keep going. We'll stop there because we start with our first number is 25. Remember, we're not going to graph on the y-axis. So our second number is 20. Our third number is 15. And then the fourth one is 10. Our fifth one is 5. Our sixth one is 0. And we could keep going, but we will stop here. And we can see we have a negative rate of change, a negative common difference, and it is going down.